Geotrig, day 2 of lesson 6. So the first problem up is what happens when we have a radical. This happens to be the cubed root, guys. There is a little 3 tucked in there. It's a little hard to see on the slide here, but there's a cubed root of x minus 5 minus 2 equals 2. So the biggest thing about this, anytime I'm dealing with any kind of radical, it really comes down to a 2 or 3 step process. And that first step would be isolate the radical. You're going to want to isolate your radical. In this case, the cubed root. You basically kind of treat it like a set of parentheses, which means you have to get rid of everything else first before you handle that parentheses. And then 2, once you have done that, then you will take the power, or say the reciprocal power of both sides. What I mean by reciprocal power is that if it's a cubed root, the exponent on that set of parentheses is actually a what? Cubed root is the same as what power? 1/3. So to get rid of a 1/3, you multiply by its reciprocal of 3. If it's a 1/2, 2. If it's a 5th root, you take it to the 5th power. And so on and so on. Yes? And so then, in step 3, once you get rid of that, you can just solve. Solve for the variable that is remaining. The biggest thing there that I have with 17,000 exclamation points after it is check for these guys. Extraneous solutions. What you're going to start finding is that the more times you square root, cubed, and cubed root, and all of those things, your imaginary friend starts reaching over from the imaginary world and starts giving you fake solutions. There are ones that end up showing up even though you did everything correctly. We've been hounding at you guys for the last 10 years of math that you guys have been doing. Check your answers. So, when you check your answers here, some of them won't work. And there just happens to be not a solution. There actually are instances where no answers that you find actually work. There'll be just no solution to the problem. Okay? So we're going to definitely make sure we're checking to make sure that we do not find extraneous solutions. So on our problem here, the first step would be what? Get rid of the 2, or the negative 2, by adding 2 to both sides. And so I end up with 4. So now I have the cubed root of the quantity x minus 5 to the 4th equals 4, sorry. And then you just ask yourself, how do I get rid of a cubed root? Not multiply by 3, but take it to the 3rd power. What I do to one side, I do to the other side. So yes, the cubed and the cubed root will cancel each other out. That's what we do. We engineered it that way. And then you just have to ask yourself, what's 4 times 4 times 4? 64. Add 5. I think everybody should agree. So x is equal to 69. So now we come up with an answer, guys. We need to just check, is this correct?
Yeah.
So we just plug it back in the original problem. Cubed root of 69 minus 5 plus 2, minus 2. Minus 2 equals 2. Remember, when checking, you can't cross the equal sign. It's like a big wall there we can't cross. So, what's 69 minus 5?
64.
64. Well, they were talking about cubed roots. Sorry, cubed roots. Minus 2 equals 2. What's the cubed root of 64? 4 minus 2 equals 2. And 2 equals 2. Check. Therefore, we have an answer. Now, this one has a square root plus another square root equals 8. I'm sorry they're using S. My S's might start looking like a 5. Bear with it. But we can still use the same 3 steps from before, but maybe add a small twist in the fact that I want to separate my radicals. Before it was isolate, now separate. So I am going to subtract the square root of S from both sides. Is that okay? It's mathematically legal, right? S minus 48 equals 8 minus the square root of S. And now, if I want to get rid of the square root, I can take the square of both sides. Now be mindful that on the left-hand side, the square and the square root will just cancel each other. That's fine. So we know our answer here is S minus 48. We like that. But the problem here now is that I got 8 minus the square root of S squared, the quantity there. No, that does not mean take 8 squared minus the square root of S squared. That's a rookie mistake. We don't do that anymore. You know, we need to FOIL it. Because remember, there's 2 of them. If you guys cannot remember the perfect square trinomial, which is A minus B squared in this case, of A squared minus 2AB plus B squared, which you guys should have seen, should know, should start to remember, because it'll make your life way easier, both expanding and factoring. Then you just have to say, okay, I have 2 of them. And get rid of the square. And FOIL. 4-letter F word. First, outside, inside, last. So, 8 times 8. 64. 8 times a square root of S. Negative 8. Negative square root of S. Negative 8 square root of S. Negative square root of S times 8. Negative 8 square root of S. And a negative negative makes a square root of S times a square root of S. It's just S. Can you guys agree that it's just going to be S? As long as Jake guesses, we're okay. Now, just gather up like terms. I'm just going to clean up each side. 64 minus how many? 16 of them. And plus S. Hey, this really turns out kind of nice. What's going to happen? What can I do? Anyone? There's an S on both sides. If I subtract S, gone and gone. In that case, then I just want to get the negative 16 by itself. So I subtract 64. So negative 16 square root of S is equal to, what's 48 plus 64? We'll just put the common sign in front, which is negative. When you add 2 negatives together, no. It makes a bigger negative. But what I'm saying is we can just say, hey, we know the number's going to be negative. What's 48 plus 64? 112. And then, of course, now we can divide, right? By negative 16. Negative divided by negative is positive. So the square root of S is equal to, what's 112 divided by 16? Hopefully it turns out nice. Bless you. Does it turn out nice? No, it's not negative 7. 7? Is it 7? Anybody going to back them up? Okay. Now, to get s by itself, take the, it's not square root, but take the square of both sides. So s equals 49. That's what we're claiming to be the answer. So now the question is it true?
It is true.
49 minus 48 plus the square root of 49 should equal 8. What's 49 minus 48? Square root of 1 is 1 plus 7. And is that true? Does 1 plus 7 equal 8? So yes, I checked it. 49 is my answer. The last type of problem, guys, is solving another system, but instead of 2 unknowns, we have 3 unknowns. And if you have 3 unknowns, you need to have at least 3 equations. So now we're going to start to encounter 3 equations, 3 unknowns, and that also includes any kind of the word problems with the numbers of blues and number of reds. You will have to come up with 3 equations possibly when there are 3 different things going on instead of just 2. The rules here apply the same way they did when you had 2 equations, 2 unknowns, as in you can use linear combination or elimination, whatever you want to call it. It means adding them together or subtracting them. We said we could subtract them. I feel it's always easier to add. You can add equations together to get rid of things, or you can use substitution. The biggest thing is that you have to do it at least twice. There's almost like 2 separate rounds. This is a 2-round fight. As in the first round, you get rid of one of the variables. The second round of the fight gets rid of another variable to leave you with just one. So this is a 2-round type of system. If there happened to be 4, then you would have to go through 3 rounds of elimination, or substitution, or mixing or matching. Okay? Now, this particular system is really kind of nice because it's missing something. Right here. It's missing a z. That means how many of them are there? There's 0 of them in this third equation. It's already done half of the work for you. I just need to get rid of z again with these 2, and then I'll have 2 equations with 2 unknowns. And look at these 2 equations. What can I do to get rid of z's? I don't have to times these ones by -1 because one's already negative and one's already positive. I am going to just add, if I do the first and the third, it'll cancel with the y's, but that means I'll have to do it again with another set to get rid of y's again. Guys, each round has to get rid of the same exact variable using 2 sets of equations. In this case, one of the sets has already been done. It already gives you, it's gone. So I'm going to take the first and the second one. I'm going to add them together and place it right underneath. Go. So let's add the first and the second equations together. 2x plus 3x is 2y plus 3y. The z's cancel. We wanted that to happen. And 14 plus 16 is 30. We basically used elimination. And now these 2 equations here, guys, look like any other system that we have done. Which means I think it'd be easiest to get rid of the x's. I can just multiply the top equation by -5, yes. So let's do that. -5 times x. Yeah, we engineered that to happen. Then negative 5 times negative 2y. Positive 10y. And 5 times 0, or negative 5 times 0, is 0. And now I'm going to add those two together. We engineered that to happen as in the x's will cancel. And what's 5y plus 10y? Equals 30. And so divide both sides by? Yes, y equals 2. Guys, we're not done because you need to find x, y, and z. Now, here's a cool thing. I can put 2 for y in anywhere I want. Where specifically would I like to put it? The third equation, because the z is already gone and all there is left is an x. Yeah. We are now plugging it into the third equation of x, which we don't know, minus, well, that's not right. 2 times 2, I'm using parentheses, guys, equals 0. So x minus 4 equals 0, or x equals 4. We know x, we know y. Now you have to go back to one of the original 2 equations way up top and plug it in there. Which one?
First. Are you kidding me? The first one. The first one.
I heard first. Let's do first. 2 times 4 plus 2 times 2 minus z, we don't know, equals 14. 2 times 4? 2 times 2?
4.
Minus z equals
14.
8 plus 4. Subtract 12. I'm running out of room. Negative z equals. I'm not solving for negative z. So we can multiply by negative 1, or you could divide by negative 1. So z equals negative 2. Guys, do not leave it like this. Sure, that is the answers, or those are the answers, but I want one answer.
Yeah, so x equals 4, comma, y equals 2, comma, x equals...
I'd rather see this as a point.
Also.
So not with the x and the y equals and the z equals.
So you just want 4q negative?
Yes, I want to see 4, comma, 2, comma, negative 2. Guys, what this actually is the intersection of 3 separate planes. As in, like your board, your desk, and something else, and they all converge onto one point in 3D space. It's kind of hard to show that on the video. This is the last problem of the lesson. I want to give you guys about 3 to 4 minutes. We got the time today. Try it. You use elimination. If you want to use substitution, you can. I think substitution, when you have a system this large, is a little bit more difficult. As in, there's just a little bit more work to it. I mean, I don't want to say difficult. It's just a lot longer to get through the process. And then we'll come back to it. Okay. Guys, the hint I said off camera was start with the z's. I'm going to put the first 2 together. Because when I do this, the z's will cancel. This will leave me with 3x plus y equals 4. Is everybody okay with that?
Absolutely.
And then I'm going to go back and put the last 2 together.
Yep.
Which leaves me with 4x minus 3y equals 1. At this point, I could get rid of the x's or I could get rid of the y's. If I chose to get rid of the x's, I would actually have to multiply both equations by something, right? I would have to multiply the top equation by a 4 and the bottom one by a 3, and then one of them would have to be negative to make it a positive or negative on each side. Instead, hey, I got y by itself. It's kind of like a blank canvas. I can do what I want. So therefore, I'm going to multiply the top equation by a, not a negative 3, but a positive 3, so that I can have a positive 3 and a negative 3. Let me change colors. We'll change to this nice dark blue. That even come through as blue? That's dark blue, guys. So I get 9x plus 3y equals 12. And then I add them together. 13x gone equals 13. Or x is equal to
1.
Awesome. And wait a minute. This is all I do now is I just work my way backwards. I'm going to take the value that I found for x here and place it into one of these equations here to solve for y. And then once I know y, I'll take the x and the y and put it over here to get the z. And that's how excited you guys should be about it. Not the original, because if you do that, then you end up with y and z again. One of these, I only have x and y. So if I put in x, I'll have to find y. And I'm thinking this top one here would be my best option. Don't you guys? What's that? They're all 1? We'll see. So, 3 times 1 plus y equals 4. Well, that's 3 plus y equals 4. Well, then y has to equal 1. I went kind of quick there. We should be at that point where this stuff is pretty routine. Yeah? Now I know x, I know y. I'm going to place it into one of these 3. Which one do you want to use? I like the last one as well.
Are you kidding me?
I just don't want to agree with anything Jake says today. So 2 times 1 minus 2 times 1 plus z equals 1. These are just gone, guys. So therefore z equals 1. And so 1, 1, 1. Okay. Lesson 6, day 2, page 52, 8 through 9, 11 through 12, and 20. Have a fantastic day.